Hello, happy Monday. Welcome back for another lesson. Okay, today we are on our last lesson of chapter 6. Again, going to be easier to do it on my computer rather than trying to draw and graph on the whiteboard. So yeah, my handwriting might be a little crappy using my touchpad, but at least you'll be able to see the graphs, which are pretty important on a system of linear inequalities. Okay. That also means after this, we're going to try and do some sort of assessment. I'm going to call it a quiz because I won't do like 100-point grades over internet stuff. But we will do some sort of assessment where I'll probably send you a Google form. Of course, that means everything from here on out is open notes, open book, open Desmos, whatever you need. Okay, because I really can't stop you from doing it. So let's get started with our last section here, systems of linear inequalities. Okay, the graphing part gets kind of hard, but really it's just doing what you've already done in 2 steps, like doing it twice. Okay. So now instead of just having one equation, we have, oh, that is not what I wanted. I gotta change my pen settings here. Now instead of having one equation or one inequality, we have 2. Okay, so basically what we're gonna do is set it up as 2 separate problems. Y is less than 2x minus 3 and 2x plus y is greater than 2. So now we just go through and do it 2 separate times. So here we say, okay, first things first, solid or dashed line, no underline. So this is a dashed line problem. Okay, so that first one's going to have a dashed line. Then I go ahead and I set it up as an equation. And then I say, how would I graph this? Okay, so like we talked about last time, look at what form it's in. So this is in slope-intercept form. So I'm gonna just use my rules for that. Okay, so I go y-intercept -3, so that means I'm gonna have a point here. Slope of 2, so up 2, right 1. Up 2, right 1. Okay, so there's my line, and I have to remember it is a dashed line, so I'm gonna go ahead and make it a dashed line through there. So there's my first line. Okay. Now, I don't want to do, I can do the last step, but I got to be careful here. I don't want to do full shading. Okay. I don't want to do a lot of shading. I just kind of want to mark where it's true. Okay. So I do a test point, didn't go through 0, 0. So I'll do 0. 0 is less than -3. That is not true. So it appears the shading is over here. And I'm just going to make a little mark kind of off the side. Okay, so I just made a little X showing me like, hey, remember, Mr. Myron, the shading is on this side. Because now I have to go through and do a second problem. So I do this one and I say, okay, solid or dashed line. Again, it's greater than, not or equal to. So I do a dashed line. I plug in the equal sign to x plus y is equal to 2. And then I say, okay, what form is this in? Well, this appears to be in standard form. Okay, so then we think back. If you still have your cheat sheet from last test, really helpful here, because right underneath where I told you standard form, I said really easy for finding x and y intercepts. So that's what I'm going to do. I'm going to go and I'm going to say plug in 0 for x. That means y equals 2. So my y-intercept is 2, so it's right up here. Plug in 0 for y, and I get 2x equals 2, because the y just disappears. Divide by 2, x equals 1. So now, if I have both those points marked, I have enough to graph a line. Now I just have to remember it is dashed. It is dashed. So there's my line. And again, with the second one, I'm going to do a test point. 0, 0 will work again, so I'm going to do that. So 0, 0 is just going to give me a 0 on the left side. So really it comes out to 0 is greater than 2. And we can tell that's not true. So opposite of 0, 0 is going to be up on this side. Okay, so now here's the new part, is interpreting where the intersection is or where the shading would be if everything was shaded, okay, for both. So it's where the two shaded regions intersect. So if the red is shaded up here and the black is shaded here, I'll notice the intersection is going to come in between these two lines. Okay, and for right now, if you have to actually go through and shade them, okay, so let me undo that. So like I like doing that part in my head, just picking where the intersection is. If you need to go through and go like, okay, red shading up here, the black line shading was down here, and then finding where they actually physically intersect, and then going in and saying like, okay, I'm gonna do black, and that's what I'm gonna call my solution, is where the intersection is. If you need to do that, absolutely do that, okay? Now, so we're not robots. Now we need to understand what we're saying. We're really just saying, what are the solutions that work for both of these at the same time? So this shading is a solution to the red line, but not to the black line, so it's not part of our overall solution. This blue shading down here is a solution to the black line, but not the red line, or the red inequality, so it's not part. Here is where both of them were true, so any answer in here, any point will satisfy both of these inequalities, okay? So that's what you found by the shading, and the shading is your answer. When you shade, that's what you're telling me. You're telling me, hey, pick any point in here, any point and going this way, okay? If those two lines extended, it's going to be basically anything up around in here also. Anything we take from there and plug in is going to be a solution to these two inequalities, okay? So that's what we're doing today, is basically taking two lines, two inequalities, and then finding where they overlap. Okay? So the got it one, I would want you to pause this and try this. I can get rid of that. I would want you to try this one. Okay, so it looks like you got about the same thing, something that's in slope-intercept form and something that's kind of in standard form minus the negative a value. But it's going to work the exact same way. So I want you to attempt that. Excuse me, sorry, I got the hiccups. Okay. Here's two more practice problems, all of them in slope-intercept form. Okay, just kind of breaking those down. So that's all I got for you today, is I want you to attempt these three problems based on the one I did. Okay, if you need to pause it on them. Okay, there's two. There's the other one. I know I've just been bouncing back and forth, so don't freak out if you're like, he's shown us 6 problems. No, it's the same 3 over and over again. Okay, take an attempt at these. If you have questions, let me know. Again, last section, so there is some assessment coming up. I did already, finally had some people reach out and say, hey, can we just Zoom and go over some IXLs? And it was awesome. Okay, we got a group of about 4 of us. I just went over IXLs with them. They gave me the problems they were stuck on. We worked through them together, got some answers figured out. It worked out well. So don't be afraid to email me and ask questions, or ask me if we can Zoom. If you know there's a group of you, if you want to text some of your friends and say like, hey, do you guys need help too? We can all Zoom, okay? Otherwise, practice these problems. Be ready for some sort of practice coming up on Wednesday, and then maybe we'll do that assessment on Friday, okay? Have a good Monday. Let me know if you need anything. Make sure you're finding stuff to do and staying busy. Email me if you need anything. Thanks.